Okay, the final set of sample problems, everybody, involves the following. I've seen a lot of tests, everybody, and a lot of the times you have to translate from a sentence or a phrase into a chemical equation. So this is really testing your ability of nomenclature also. So this is a nice cumulative type of problem, everybody. Solid zinc, okay, reacts with aqueous lead-2 nitrate to form aqueous lead-2 nitrate, zinc-2 nitrate, and solid lead. Let's go ahead and translate it. Okay, so zinc solid reacts with lead-2 nitrate, going on to form zinc-2 nitrate, aqueous, and solid lead. Okay, let's go ahead and balance this. So we're going to need 2 zinc nitrates. Oh no, it's going to be zinc-2 nitrate, I'm sorry. So this is going to be 2 of these. Okay, I'm going to erase that coefficient, everybody. Very sorry about that. And that's, yeah, so my balanced chemical equation is good to go. Okay, so this is an example of a single replacement reaction, and everybody, if you go ahead and look up the table, the activity series, zinc will come in and knock out lead, everyone. Okay, second example, solid iron reacts with molecular chlorine gas to form solid iron 3 chloride. Okay, so solid iron reacts with molecular chlorine. Remember what we mean by molecular chlorine? Okay, that's going to be Cl2 gas, not just Cl. And that's going to go ahead and form solid iron 3 chloride, FeCl3 solid. All right, let's go ahead and balance this. Well, iron's good to go already. I got 1 on each side, but I got 2 chlorines on the left, and I got 3 on the right side. And so we can go ahead and simply put a 3 in front of the Cl2 and a 2 in front of the iron Cl3. And finally, I'm going to need 2 irons. Okay, so this is again an example of an even-odd pair where you could have used a fractional coefficients, everyone. That would have worked too. All right, this is an example, everybody, of what we call a combination reaction, where we have the form A plus B goes on to form AB. Once again, a combination reaction. Okay, last example, everybody. We have solid barium peroxide forming solid barium oxide and molecular oxygen gas. Let's go ahead and write this and balance it. Okay, so we got solid barium peroxide. And you're told that this forms solid barium oxide in combination with molecular oxygen gas. Remember, molecular oxygen, everybody. Okay, very important. So that's going to be O2. All right, so my bariums are good to go. So the only thing we got to balance are the oxygens. So I got 2 oxygens on the left. I got 3 on the right. Let's go ahead and put a 2 in front of BaO. And that's going to give me 4 oxygens on the right side now and 2 bariums. And all I got to do is put a 2 in front of there. So I got 2 bariums on both sides of the equation. I got 4 oxygens on both sides of the equation, everybody. And this is what we call a decomposition reaction, where we have one compound AB essentially dissociating into A and B. So one compound forming multiple products. Okay, so this is a nice cumulative exercise, everyone, where it really tests your ability, your knowledge of the nomenclature, and of course to balance a chemical equation. All right. Thank you very much for your time, and I'll see you next time on Educator.com.